All right, today we're gonna explore periodic data, and our objective is we're gonna look at things or patterns, and we're gonna identify if something has a cycle and if it's periodic, okay? And then there's two more things that we're gonna do. We're gonna talk about the amplitude and midline. These are really easy items, okay? So if you look at these four pictures, what could you say is a common thread between this? This looks like the Earth. What does the Earth do?
Move.
Uh-huh. How about a heart?
Beat.
It beats. How about this? This is a
Swing.
person that swings.
Moving.
They go back and forth, back and forth, back and forth. Okay, and what about this?
Ocean.
Rolls over.
That's waves. What do waves do? The ocean
Like roll over.
goes up. Do you see the pattern? Do you ever sit at the beach or at the ocean? What do you see? You see a pattern. The waves come up and go down. So these things are periodic. They're periodic. They have a pattern. And they have a cycle. Do you notice that, like the waves? Do you ever sit at the beach and you watch the waves come in and then they go back? And then what happens? They come in. So what's happening? We have a cycle. The cycle is starting over again. So if that pattern, if the change of the y values is if you can do a change that's a pattern, if you see a constant change throughout your cycle, we say that it's periodic, okay? So the big picture is periodic behavior is behavior that repeats over intervals of constant length, okay? So look at this first example right here. We need to decide, is this periodic? Yes, it is. It's periodic. Why? Because our y value has a constant length. See, from here to here, it's constant. Now, what would make this not periodic is, let's say it went higher and then lower. You didn't see a pattern. If you didn't see a pattern, it would not be periodic. Now, the length of a period is where you can identify the cycle beginning and ending. And it can vary depending on where you start your cycle. For example, if you're looking at the waves coming in at the ocean, that's periodic. But where would you say the cycle begins? Does the cycle begin when the water's at your feet on the sand? Would you say, okay, that's the beginning of the cycle? Or would you say the cycle begins when the water is high, when you see the wave high, and then it comes back in, and then it goes out, and then it goes high again? Where does the cycle begin? So if you analyzed this periodic function here, if we started from here, this point right here, everyone see where my pen is? Travis, we're on the screen, right?
Yeah.
Okay. I'm going to start right here at 0. Ignore what it says here. But if I started my cycle right here, can you trace with me and tell me where this cycle begins again, or where the period begins again? So everybody, look at my pen right here. Right here. It's right here. So I'm going to go up. I'm going to tell me when I start repeating.
Right there.
Right here.
Up. Up a little.
Right here.
Yeah.
Right there.
Wait, can you repeat what you said?
Okay. I need to identify one full cycle, where it could start and where it's going to start repeating again. So if I look, I'm going to take a highlighter. And I'm going to start, because it's probably easier if I highlight it. If I started right here, right there, Tell me where my cycle is repeating. So here, here, is that it?
Yeah.
That's it?
No.
No, we gotta keep going. We gotta go down there and right there. So, right up to there. So from here to here, that is one full cycle. Cause then what happens? It starts again from here to here. There's another cycle. So that is considered one way to determine one full cycle. The person who wrote this book decided that one full cycle was from this top right here to this top right here. Or you could have evaluated it from here to here. In any case, what is the same? Can anyone tell me whether I evaluated it from here, from this spot to this spot, or from this spot to this spot? Can you tell me what stayed the same?
The pattern.
The pattern really,
Slow.
Do you want to?
okay, where it okay, I get what you're saying, but what else?
How
Think
long it is?
how long it is. The length of the cycle, regardless of where Kaylin or Chelsea or D'Angelo or Jack, wherever any of you guys started to where you ended, if you looked at the length of it, the cycle, the distance of the cycle stayed the same. So if you went from here to here, how long is it from here to here? It's 4 units. What if I started here and I would go to here? Guess what? That's 4 units. What if I did it from here to here? That's 4 units. Regardless, our cycle is 4 units, okay? So you flip to the next page. I want you to look at these 2 examples carefully. This is a periodic function. Can you tell me the length of one full cycle? How can you tell me what the length of one full cycle is? Well, every single one of you guys is going to pick a different start spot, right? So let's say if someone started here, at this point right here, which is -4, if you start here and go here, tell me when the cycle repeats itself. Tell me when to stop. Okay, you got it. And then it repeats itself. You are absolutely right on. So, from here to here, that was one full cycle. Now, did anyone start their cycle here? If you would have started it here, it would have started again where? Here. So from here to here would have been one full cycle. What if I wanted to start right here? Where would it start again?
Right there.
Right there. In any case, can you tell me the length of one full cycle? What is it? How many units did it take to complete the entire cycle?
4.
The pattern before it
4.
4. That's your first objective. Did we hit our first objective? Can everyone in this class tell me the length of a cycle? Yes or no?
Yeah.
Yes. Okay, so this cycle, the period we're gonna say is 4. How about the next one? Can you tell me the length of this period?
3.
How'd you get 3?
I started at 0.
Started at 0, so you started, Warren, did you start right up here?
Yeah.
Okay, and then where'd you go?
Down.
Down,
And then all the way up to the next
and then
peak.
up. Perfect. Now, did anyone do something different? Probably. We don't all think the same. But can you tell me, Lauren, what your, what the cycle is? 3. Because these are going by ones. So 1, 2, 3. So this period is 3. Easy?
Yeah.
Okay, now, not all functions are periodic. For example, check out this one. This is a function, right? It's a function. But is or is it not periodic? Is it periodic? So let's see if we can trace one full period. If I started here and I wanted to see where the pattern repeats itself. So it's going up. Tell me where to stop, where it's going to repeat itself. You think here? And then if it's, okay, so then if you thought there, okay, now I see what you're seeing. You're seeing this pattern, but the distance of your y value is not the same. So this one is not periodic. For it to be periodic, it would have to, if we wanted to make this periodic and we wanted this to be the cycle, we would go here and then we would have to do this pattern again this way. It would be, the distance, your y value would be like along here. So this is what's not making it periodic. So this one is not a periodic function. It is a function, but it's not periodic. Now what about these? Check these. These are the same graph, by the way. This is the same thing. One is just a little bit more analyzed. So if I asked you, is this periodic? Well, let's see if we can trace this pattern. If I started here, and I wanted to see if this pattern repeats itself, I could go down, and then it's going up. Okay, so from here to here, that looks like one full period. Now, is that pattern from here to here, is that repeating itself?
Yeah.
It is. It went down, and it did the same loopy thing, and went back up. It looks like it's gonna go back up again. So, this is periodic. It is periodic. Because our change in y value is constant. Okay?
Would that be 10?
So, yes, to go from 0 to 10, our period is 10 units. Very good. Here is 10 units. Check out the next two. Is A periodic? Yes or no?
No.
Why not?
Because y values are constant.
Very good. The y values are not constant. So this one is not periodic because our y values are changing. There is a pattern. Is there a pattern? Yeah, there's a pattern, but this one's not periodic. How about the next one? Is this one periodic?
Yeah.
Yes. Can anyone tell me what the length of one full
2.
cycle is?
4.
You say 2. I'm gonna say
4.
4. The period is 4. Period is 4. Now, everyone look at this graph for a second. Okay, there's two things that you need to know. One is called the midline. The midline is a horizontal line that cuts this graph in half, horizontally. So, see these boxes? These boxes are going up by 1, right? We have 1, 2, and then we have -1. If I were to cut this graph halfway, does anyone know what the halfway mark is? What horizontal line would you say that this x-axis is in the middle of this graph? See this, see this right here? Would you say this line is halfway between this highest point and this lowest point? Is that halfway?
Yeah.
No.
No.
You see that from here to here is bigger than from here to here, right? Does that look halfway? If we were to pick up our x-axis right here, and if we could move this line, where would we move this line so it's cutting this highest point and this lowest point right in the middle? Where would I move it up? Between what?
0.
Between 0 and 1, actually right halfway between here. See this imaginary line right here? This line, now does it look proportional? Do you see that from here to here, and from here to here is the same? Does everyone see that? This distance from here to here is called the amplitude. The amplitude is the height off the new x-axis. In pre-calc, we call this line the new x-axis. The new x-axis. This new x-axis has the equation y equals 1/2. It's halfway between this number and this number. Now, can anyone think of another way to find a halfway mark? Halfway. What did we do in this class a few weeks ago that did halfway mark? Halfway, middle. Think. How can we figure out a way to get something in the middle?
Something divided by 2.
Bingo, average. So, if you want to find the middle, which is average, can you tell me what this number is? It's 2. This is 2. Your highest number is 2.
And the lowest.
And your lowest is -1. So if we were to add these two together, what's 2 plus -1? And divide by 2. What do you get? 1/2. That's how you find the midline. So, the midline, I'm just making this up, it's this right here. So, if you flip to the next page, here is your midline. Here's another periodic function. These look like teeth, don't they? They look like molars. Doesn't that look like a molar, too? So, anyways,
It's a good apple.
how do you find the midline? How do you find the midline? I can give you all the definitions in the world, but I want this to make sense to you. The midline is the line halfway between the, what's this called right here? What's this top number called? The maximum. Give me the number, 2, 3. The maximum is what? Is 3. The minimum is where? Is what? Minimum is what? Everyone? Maximum is 3, minimum is -1. How do you find the average? You add these two up and do what to that number? Divide by 2. Add these up and divide by 2. So what is 2 over 2?
1.
So guess what? The midline is y equals 1. Y equals 1. Now, how do you find the amplitude? The amplitude is the distance, how high that graph reaches, the highest point. How high does it reach above that amplitude, that midline? So if you, here's the picture of the midline right here, y equals 1. So the highest distance is from here to here, or from here to here. Can you tell me how many units that is?
So,
It's 2 units. So the amplitude is 2. Don't go by the lowest, it's always the highest, the biggest gap between your midline and your either your lowest point or your highest point. So your amplitude on this is 2. Now, mathematically, how do you find the amplitude? Instead of adding the two numbers and dividing by 2, you subtract the two numbers and divide by 2. So if we were to take 3 and subtract -1, now we're going to subtract -1. We take the highest number and we subtract the lowest number, divide by 2. You get 4 over 2, which is 2. That's your amplitude. So your midline, think of average. Add, divide by 2. If you want to know the amplitude, you can do one of two things. You can look at your picture and count units, or you can subtract the two numbers and divide by 2, and that'll give you your amplitude. So that's what this right here. Here's another example. Let's check out this example right here. So I'm telling you that this is periodic. It's periodic. Now I'm not asking you what is the length of the cycle. If I asked you what the length of the cycle is, can anyone answer that question for me? What's the length of one full cycle? That's one of your objectives today. Give me the length of the cycle.
Is it 5?
0, when is this thing repeating itself? Do you think it's 5?
I mean, I kinda did it in my head.
6.
6?
Wait.
Yeah, it's 5.
I got a 5,
5.
I got a 6.
No, it's 5. 5.
Okay, how many think it's 5?
5.5.
5? The period, you guys, everybody. How many think it's 5? How many think it's 6? How many have a different answer? Does anyone like me think of a different answer?
3.
I have 10. High five. I got 10. How'd you get 10? Because I got 10. How did you see 10? Because I saw 10.
Every box is 2.
Every box is 2, but when is this pattern repeating itself? You guys gotta see this.
Because it goes.
Because I'm scared that you saw 5. This thing, if I started here, this thing, it's not repeating itself here, right?
No.
No, it goes all the way back up.
It's gotta go back up. That's where it starts again.
Yeah, it's 5, right?
No, from here to here, you guys. You gotta read are you looking at these numbers
Oh,
down here?
what I did, I just counted.
Oh,
I didn't-
that's how you guys
I
got
counted
5.
Yeah, I didn't know that was by 2, I didn't look at that.
Oh, yeah, read the boxes.
Yeah, I counted.
Okay, I apologize. If you understood these boxes as 1 unit, then yeah, I guess it would be 5. But they're going by 10.
It makes sense now.
It makes sense? Okay, so, do you guys see the period is 10 units? Period is 10. If I wanted to find the midline, you're gonna take your highest number, which is what? What's the highest
4.
number? 4. Take your lowest number, which is?
-1.
Mm,
2.
these are
Oh,
going by
-2.
2s. So 4 plus -2 and divide by 2. What do you get? What do you get? Hello?
1.
Yep. So y equals 1 is your midline. Now what if I wanted to find the amplitude? The amplitude, you take your highest number and you subtract your lowest number and divide that by 2. So you're adding to find the midline and you're subtracting to find the amplitude. So this would be 6 over 2, which is,
3. 12.
and you don't need that y equals,
3.
your
12,
amplitude.
3.
Amplitude would be 3 units. So how high off the x-axis is this graph? It's 3 units. So 2 more objectives. Can you find the midline and can you find the amplitude? Okay, last two, and then you're on your own. Can anyone tell me what the midline of this is?
The highest.
What's the highest?
One.
And these are going by ones. This is a 1, this is a 1,
And the lowest, which is -2.
and -2. What do we do with those two numbers?
You add them, divide by 2.
So 3/2, that's your midline. So your midline is 1.5. Wait, did I do that right? 1, oh, this is a -2, I'm
Maybe
sorry.
not negative.
My bad. 1
1.5.
plus -2 over 2. So it's -1/2. So -1/2 is called your midline. That's your midline. Y equals -1/2. Can you tell me what the amplitude is?
So from -1/2, you have to go to the highest point.
Yes, exactly. So from here to here, you can count the number of units. How many units is it from here to here, you guys?
1.5.
1.5. The amplitude is 1.5. Now, what if I wanted to do it mathematically?
Then you have to do 4.
You do 1 minus
Yeah, 1 minus 2.
-2 over 2. So it would be 3/2, which is 1.5. You get it? It's easy, right? Okay, we are done. So the 3 objectives are, can you tell whether a period is cyclical and whether or not, what the period is? Can you find the midline? Can you find the amplitude? Can you tell me the number of units a cycle is? Can everyone do this?
Yeah.
Everybody?
Yeah.
Anyone confused? Okay, the back page is your homework.